Hello and welcome. My name
What's
is
up,
Wes
everybody?
Bunn.
I'm Sam Deiter.
And today we're going to be showing you some stuff with motion controllers in VR. So Sam and I have been working on a little mini game of sorts that we've set up with some motion controllers in VR. And we're going to show you that project here. It's something that we are continually working on and something that we want to release down the road with a bunch of different examples on how to use motion controllers in different ways. So we're going to cover that, and we're also going to talk about some material stuff if you want to chime in on that real quick.
The other thing that's important with VR is performance, and the best way to keep your performance reined in or keep your performance in check is to build something that's performant right out of the gate. And I'm going to go over a few things to keep in mind while you're making your content and a few experimental tools inside of Unreal Engine 4 that make optimization so much easier to do and so much of a less manual thing than would be another workflows and things like that. So let's go ahead and jump into it, man.
Yeah, I think we're going to jump in. We're going to show you the finished project, and then we're going to kind of walk through it step by step, how we did it. We'll walk through the whole project together so you can see all the bells and whistles and how we put it together. So we're going to turn it over to the screen here. I'm going to put this headset on and try not to lose my mic as I do so.
Or smash me in the face with the motion controllers. It's horrible payback.
And I think there goes my mic off my ear.
Here, do you need some help? Here,
See.
you do that.
Okay.
You got them?
I think so.
All right. I have to move out of the way a little bit or I'm going to get smashed
Although
in the
I am
face.
off-centered a little bit now. Let's actually reset this maybe. You gave them to me in the wrong hands here.
Oh, sorry.
There we go.
We need to label those.
Yeah, we sure did.
It gets really confusing. Which one's the left one? Which one's the
let me
right
go
one?
ahead and talk about what we got here. So the first thing we got here is a simple carnival game. We got the traditional can toss. I don't know if that's the actual name for it, but
There's can toss, milk bottle
milk
toss.
bottle toss. There's tons of variations of these. The North Carolina State Fair was in town not too long ago, so it got me thinking that'd be a fun little VR game since they took all my money when I was down there. So I thought we would go ahead and do that. So what we have here, we have our motion controllers. These are our hands right now, these two little boxes that I'm looking down at.
We'll get better hands.
Yeah, we'll get better
Just been
hands down the
busy.
road, but you can kind of see, we'll show you how we set these up. We kind of touched on this in the previous
In fact,
Twitch stream that Sam and I were
I
on.
do believe you used the tutorial to set these up. That is live right now on our website.
Yeah.
If you go to the VR section, you can see how to set up motion controllers, and we use that tutorial to set this up just to make sure that the tutorial was actually correct and that other people could use it. So it's definitely on point now.
Yeah, we took it a little bit further. I remember now that when we covered this, we showed attaching things and stuff like that. We couldn't actually move, but now we can actually move around. We'll show you how we did that. We're using the left trackpad here and the right trackpad to kind of look around. Now you could turn your head and look if you prefer to move in that direction that you're looking. You could set it up that way. Because I'm sitting down, I figured I would use the right stick, left stick, the traditional twin stick. To kind of move
that was
around.
actually something we found. Rotating your head worked, but if you needed to go like behind yourself, you just needed a little bit of extra control to not make it so that were wrap yourself around the cord or straining your neck to look behind yourself and then spin back around. So
yeah, it's totally a preference thing. Personally, I like the experience of sitting in VR but having the traditional game control setup. So this feels pretty good to me. The other thing that we added here, if I press the right trigger on my right stick here, got a cool lightsaber. If I press the left one, we got two.
Oh.
So this will be the next one that we will try to focus on, our lightsaber battle. But figured we should add this because the object of the game, obviously, is to throw the ball at those cans and knock it over. But if you look at my square, I'm not really getting an indication of where I'm going to be throwing it. So to kind of help alleviate that, we just added this little particle effect so you can kind of line it up to see where you're going to go and then go ahead and throw the ball.
you increased your accuracy by like 100%.
It did help a lot, actually,
adding
once I did that.
There.
Well, when I was debugging this, I set up a line trace to see where I was aiming, and I thought, wow, this is actually helping a lot more. So let's just add a particle effect and actually have that appear so that you can kind of see where you're aiming. So we have a button on the left here. If we go over and press this button, it will restart the game. So I can go ahead and just not hit Sam in the face, press that button. And in the far back up there, we have a UMG widget. It's a 3D widget that is just an actor with a widget component added. And we'll step through that in a second here as well. So we have three balls here, and I can walk over to one of them. I can reach over and pick it up, and it gets stuck in my hand there. There's Sam's nice material for his the baseball there that we created. And obviously, if I just try to throw it at these cans, let's see if I can knock them down. So I throw it, And that was terrible.
Dude, that was a
perfect throw,
hit,
too.
though.
Now, one thing I did want to mention about this is physics-based, and there's some things that still need to tweak on this.
We need to add physical materials to mess with
Right.
restitution, friction. Restitution is bounciness, in case you were wondering what it is.
Right.
To just give them a little bit more weight when it hits off of them. Because right now, like Wes said, it's purely physics-driven.
Oh, I missed.
Oh,
Look at that. Get on there, I still lose. But you see, I lose up there. I had one more can remaining, but I could go over and try again. And
out of the way.
let's see. I'll give it one more shot here real quick. So it'll reset the game. And the intent is to have several booths like this set up. As we jump into the material stuff that Sam wants to talk about a little bit later, we'll kind of show you what we're planning to do here.
You'll see some of the games and some of just the rough framework that I put together to make this super modular and super reusable for VR. You know, you want a lot of asset reuse in VR to save on. Oh, look at that. It's almost like ball in a cup.
Almost. Yeah, so I could switch hands. I could throw it with my left hand if I'm left-handed. See if I can actually do that. See if that helps. Oh, nope. Missed. The other ball fell on the floor and fell out of the play space here, so we deleted it. So we'll show you that as well. So let's actually take a look at the project here, kind of see how we set this up. So we take this off for a second and put that down.
Somebody was
Turn it
asking. Yeah, there are actually wrist straps on these, and you missed it. I threw it across the room earlier today when I was setting it up. I was playing some slashing game, and it slashed right out of my hand onto the floor. So we've already dropped it once a day. That's all you get.
I'm going to move this over here out of the way. Okay. So we are looking at the actual project now. Again, I just wanted to walk through this real quick before we jump into some of the other stuff that we're going to talk about here today. Again, if you have any questions, feel free to put those in, and we'll try to respond to those as we go. So the first thing that we did, we added some additional inputs for our character. We started out with the first-person template project just because it had a built-in kind of perspective that we wanted to take. It had some built-in functionality for us as far as moving. So we just added to that. We went up to the project settings here, went to the inputs, and added a couple additional inputs here.
We should actually talk about resetting this, the D-pad.
Yeah, I was going to. I was going to.
Okay.
I was going to get there. Right? You're getting ahead of yourself there. So as Sam was just going to mention there, I'll talk about that here in a second. The D-pad setup. So we have some action mappings. We have the right hand use and the left hand use. These are just bound to triggers. If you set up inputs before, you should feel right at home at setting up inputs for motion controllers. They're all right there inside of the drop down. So if you click the drop down, you could search for motion controller. If you could spell it. Yeah, like that. And you can see there's all the motion controller options right there that you can assign for the different buttons, for the triggers, for the trackpad, etc. So what we did, we just added the right trigger and we added the left trigger. There's also grip buttons on the side of this. There's a left and a right grip. And I did some experimenting with that. I know Valve is working on the final, I guess, what is it? The final product, the version of this controller here that's going to be a little bit more easier on the hands to hold, I guess.
A little more ergonomic.
Yeah. I didn't want to reference any other products, but they're working on a better version of this and holding the grips right here. Sometimes you would hit the trackpad. I found that distracting, so I put it on the trigger just because it was easier.
I think the grips are also a left and
It is.
two separate
It's
buttons.
two separate buttons. That was the other thing.
It feels like one button. There's a
Right.
button on the left and a button on the right. So just be wary of that when you're trying to set them up.
Yeah. So as far as the actual movement, like Sam mentioned earlier, when we were working on this project, we set it up in about a day or so. Half of the day was spent trying to figure out why I couldn't move backwards. And after some research, I figured out what the problem was. The touchpad on here, first of all, is touch sensitive, so it's kind of like a iPhone if you...
Or it's like a laptop.
Yeah, kind of like a laptop.
Like a little thing like, let's see, where is it? Like this right here. It's exactly like this little trackpad right
So
there.
it's very sensitive. You don't have to push and click it, although there is a push-click as well. The general movement is done by the touchpad itself. So I could move forward, but I couldn't move backwards, and I didn't know why. It was only giving me 0 or 1 values, access values. I wasn't getting negative ones, so I couldn't move backwards. And after some research, we found out that we needed to recalibrate the touchpad. And you can do that by holding the trigger and pressing the little black button on there. That'll allow you to reset it, and you should give you that full access.
It does make a beeping noise once it's been recalibrated.
Yeah, there's also another one for repairing if you accidentally unplug your USB or need to repair it for any purposes. You can press
drops out for
the little black
reason.
button and the red button together. That will give you a different sound as well to let you repair it.
And then it'll be repaired, and then you'll see. Shelley, we can go back over to the screen. You'll see in the compositor that we've got both motion controllers up, and then the 2 squares are for the lighthouse trackers.
Mm-hmm.
The red thing is for the headset,
which
and
isn't on right now.
it's not on, so that's why it's giving us a little bit of an error there.
So the only thing that we did for the access mappings, we just added an additional input for the motion controller for the left thumbstick. If you're at home working with gamepads at all, it's going to be very similar. So we just set it up very similar here to the left thumbstick here. So we're moving along the y-axis here. And for moving right, we did the left thumbstick in the x-axis. So that is our left stick movement. And then the right stick, this is totally optional. We just did the right thumbstick along the x-axis here.
Yeah, and I wasn't really sure how being able to turn and using I thought that was going to induce motion sickness, or simulation sickness, I'm sorry, and it actually works out really well. I actually really prefer it like that.
Yeah, because then you don't have to turn your head to move in a direction. You can just kind of be in the environment and move around.
Like the lazy Wii.
That's how I like my VR, okay? So with all of our inputs set up, the first thing that we did is went into our first-person character here. This is our pawn that we are controlling. And we needed to add components for this, and we covered this in the previous Twitch stream. We added some components. You can go to the components window up here, click add component, search for motion controllers. Not the Leap Motion, unless you're working with Leap Motion controllers. Just the regular motion controller here. Once you assign that, then you can go to the details panel and define which hand that motion controller corresponds to. There's some other options in here. We haven't had to mess with those too much when playing with motion controllers. It's really just this section.
I think a lot of this stuff is just the way that Unreal works. You get a lot of other things like, like cast shadow and things like that. So when you do the motion control component, as Wes said, it's literally you just set one up for the left and then one up for the right. Ours is L _motion controller, R _ motion controller, and that's literally all you have to do to get them set up. And then attach a mesh to it so you can actually see what's going on.
Yeah, because there's nothing. If I go to the viewport here, you can see our little character with his little boxy hands. Obviously, if we had a skeletal mesh, we would use hands and make it look a little bit better.
We were working on that, but other things came up that we had to jump on for another project we're working on. So we'll have hands eventually. It's one more thing to add to the pile, right?
Yep. So I'm just going to step through these components real quick. All we did was to provide a way for us to pick objects up. We created a collision, and whenever that collision overlaps something, that tells us, if we're in range to actually pick up the object. So we just created a box collision here. Our box is pretty big. If you had, like I said, hands or something, you could use spheres or whatever you'd like for your collision. And then there's our mesh representing our hand. I also added an arrow component. I use this arrow component, again, because we are not using skeletal meshes, as a way to define where we want to attach the objects that we pick up. If we had a skeletal mesh that had bones in it, we could have a bone, specifically for gripping items or something like that. We could attach it to that particular bone. But this gets the job done, so we just added an arrow component. And then finally, there's our particle effect, which is off in the viewport here because it's activated when we hit our trigger. So that's kind of how we set up our components. We did the same thing for the right hand, so it's just set up the exact same way so that we have both hands that we could use if you're left or right.
Did you just make one and duplicate it, or did you just add
I duplicated the components.
Okay.
Unfortunately, you can't right-click and copy and then paste all of these just yet.
Okay.
But the settings will carry over for each one that you copy.
Okay.
So
all right. So yeah,
I created all the components that I needed and then just nested them. You probably could have also nested them directly under the motion controller so that everything follows along with it. But for clarity, I nested them under each other so that I can collapse and do things like that.
That makes sense,
so
right? Separate the right and the left.
Yeah.
It makes it easier to debug too if there's ever a problem.
Now the other thing I did, just because when testing this, I shrank the size of the collision capsule here, just so it's a little bit narrower because it was wider than my actual body. So I would go up to
Probably colliding in when you're
right.
hitting.
I'd go up to the little stand to pick up the balls, and I'm like 5 feet out, and I can't reach it. I couldn't figure out why. I was like, oh well, collision's hitting it, so I needed to get in a little bit
You're
closer.
horizontally challenged.
I think that's it. Yeah. So on the event graph, there's not a whole lot we did here. Actually, there is a little bit, but we'll get through it real quick here. First thing that we did on the event begin play here, we set it to follow our HMD orientation here. We just did that by getting the controller and the camera manager here. We set that to true. Now this is if you want to independently move your head while moving. If we left this off, our whole body would turn along with the camera, which we didn't want. So
Which makes it really hard to pick things up.
yeah, so this is just a matter of preference, how you want to set it up. For the stick input, here's our turn rate. This is our right thumbstick here. This is very similar to what was in the template, actually. We have a variable here that controls how much, at the rate at which we turn. If you've looked at the first person template at all, this should look very similar, actually, because it's kind of the same setup. For the movement input, we're just using the move forward and move right that we set up and plugging those access values directly in, like so. The real meat of this blueprint here that we made changes to was actually picking up objects, determining when we are in range to pick up objects, what happens when we pick them up, etc. So I'm gonna hop down to that section real quick. So we have our right hand pickup here. And what we've done for this is, here is our input action event for our right hand use. So whenever we press the right trigger, which we've defined this as, first thing we're checking is a Boolean that we created, is our right hand in range? Can we actually pick up an item? Otherwise, we'd be able to pick it up from anywhere in the world. So it's pretty straightforward there. This Boolean is actually being set when our collision overlaps an object. So here is our on component begin overlap for our triggers. So this is the right trigger that we are searching. When we overlap, first of all, we're checking, do we have something in our hand already? Because we don't want to pick up a ball if we already have a ball in our hand. So that's the first thing that we're doing. If either of those are true, we're not going to do anything. If we do not have a ball in our hand, then we're going to make sure that it is the ball that we are actually picking up. And this is a separate blueprint. It's just a static mesh. It's just a ball. It has some script in it that we'll take a look at in a moment, but it's very simple. Once we determine that it is a ball, we're going to save that as a variable so that we have reference to it for later. And then we set that right hand in range is true so that we can actually press our right trigger and pick up the ball. Now when we actually are able to pick up the ball, we have a custom event that we created that's called pickup ball, and we added some inputs on it. The first thing that we added is our hand, quote unquote hand, which is our right arrow, and the ball to hold. And the ball to hold, as we mentioned, is being set here when we overlap the actual individual balls. And once we go through this script here, we'll hop over to that in a second. We then say that a ball is in our hand so that we can't pick up balls again. And then we activate our little particle effect here so that we can see where we're aiming. If we are not in range, we also set the particle effect to activate just so that we can test out without holding a ball to see where we're aiming. So that's why we set that there. For the actually picking up the ball, if I double click on that, we'll jump to that. All we're doing is attaching it to that arrow component. So our hand is the arrow component. You can see it right there that we've set. That's the parent. The target is the actual ball. And then we are snapping and keeping the world scale. So it is now attached to our arrow that moves along with our motion controller. Very simple stuff here. As far as dropping the ball, when we release the right trigger, first of all, we want to make sure that we have a ball in our hand. Otherwise, we could drop nothing, or we could set that we are no longer holding a ball, and all kinds of funkiness is there. So we want to make sure that we do have a ball in our hand before we could drop it. If we do, then we're going to call this drop ball here. We're going to specify the ball to drop, and we're just detaching it there at that point. So we're detaching from the parent, maintaining world position. We are detaching the ball, and we're also going to set simulate physics to true, so that we can drop the ball in air and it fall down to the ground and react as you would expect. Now, the reason we didn't set physics on by default, one of the things I noticed, you walk up to the table and go to grab a ball and accidentally knock it into the play space and lose that ball.
Yeah.
So the balls are static by default, and then you can go and pick it up. Once you release it, then it turns into a physics object. So very simple stuff for picking up and dropping items. So this kind of setup here could be used for anything, not necessarily balls. It could be guns. It could be
it could be actually
bats, it could be
any object in the world that you
want
want to pick up or put down.
Right. And let's see, what else do we have here? So the rest of the script down here is for when we overlap and stop overlapping our balls here. So that's the right hand. The left hand is an identical setup. We're just swapping out, the left arrow, setting which hand a ball is in, etc. That's pretty much it for the player character. Everything is set up for us to pick up and drop balls at that point.
They're like, oh, that's typical carny game logic. You hit one ball. No, you only got two left. Sorry, you got to find more.
Yeah. So the way that we went about setting this up, everything is modular so that we can take all of these bits and pieces and repurpose them in other carnival games that we want to try to create here. So we have this scoreboard, which is its own blueprint. Well, that's a wall, but our actual scoreboard here is its own blueprint. Our reset button is its own blueprint. The balls are their own blueprint. The cans are their own blueprint, etc. And then we have a little dinosaur hiding under the table. And this dinosaur is the main blueprint that controls the logic for this game.
I would say maybe like the parent, I guess.
It governs the rules, essentially.
Okay.
So I could take this piece and just plop it down somewhere else. So if I go, here it is, the can game blueprint, I can just take this down, plop it somewhere else. It has triggers and everything in it so that I can move the triggers around.
And then we use the eyedropper over there to pick what we want to use within the world.
If I get rid of, I could probably, I don't know if we're going to lose our...
just pull it over
Yeah,
the
I'm
other
going to
side.
pull it out. I don't want to lose our thing
Yeah.
there. So here's our details panel. I just removed it from the other side here. Has some properties in it set up for us so we can define what's the target scoreboard for this game. We could just use the eyedropper, as Sam mentioned. I could specify to click the drop down, pick which scoreboard, because we could have multiple instances of this. Same with the reset button. It's going to reset this particular game, not any other game that we could potentially have. Now there's some other variables that we exposed. We exposed, the cans remaining, max cans, the number of balls that we wanted to have, etc. There's also some parameters for adjusting the size of the quote-unquote scoring area and the out-of-bounds area. I think it happened once during the demo that I was showing a moment ago that I lost a ball because I dropped it and it fell out of our little play space here. So we need to be able to track what happens if you throw a ball out of the play space. So that's why we set that up there. So let's take a quick look at the ball blueprint because it's really quick. It's very similar to the projectile, actually, because we're creating an impulse at the point of impact. And this is something that I'm still kind of playing around with, how much impulse to create. So I noticed if I set it too high, then the cans go flying. If I set it too low, then they don't move at all. So still kind of messing and tweaking with these values here, but we're just making sure that it is a can that we hit. It's not another ball that we're hitting and generating impulse on, etc. So that's this script here, and it's just a static mesh. That's all it is. So that's our ball blueprint. The can is probably the most simplistic blueprint that we have. It's actually just a static mesh. The can. That's
I'm
it.
like, wow, that is really simple.
There's no script in here.
I was like, then he's going to go to the construction script, and it's going to be huge. But
Nope,
no,
that's
nothing.
it. It's just a blueprint, simple blueprint actor. Let's see, what else do we have? The scoreboard. I'll take a quick look at this. So we have created, through UMG, a widget. So here's our actual widget blueprint. And I didn't want to go into too much detail about this UMG setup here, but we'll cover it real quick. So we just set up a simple vertical box. It has some text in it for the amount of balls remaining and some instructions. We set our UN text to hidden by default. We're turning that on through script. We'll show that in a moment. And then we have some text for when the game is restarted, etc. We set some of these to variables so that we can derive these through blueprint script. Now, there's no actual logic being handled inside of this widget blueprint. If we go over to the blueprint actor, which we've created a simple actor, all we've done for this, if I maximize this, is create a widget component. If I go to the viewport, so it's just a widget component so that we can place this in 3D space. I think we've done some Twitch streams on this as well. There's a couple how-tos on the official documentation pages as well, how to set this up. I think it goes even more complex than this. It's a menu, like a main menu in 3D space. If you want to check that out, feel free to check that out. But we created a simple widget here, made some minor adjustments to it in the details panel here, just increased the draw size so we could see it a little bit better. And on the event graph, we have no script in here. This is all the script for updating this is being handled in that dinosaur blueprint.
Ah, okay.
So we can go ahead and close this out. And let's actually hop over to that because that's the real magic. So there's a couple sections in here. We'll cover this and then we can wrap this up here. So the first thing that we did, we added 2 components. If I go to the viewport tab here, or 3 components. First component that we add is just a box collision that we're using for our scoring area. When a ball lands in this area or a can lands in this area, we're treating that as the scoring area. Then we also created the out of bounds volume. So when I leave this volume, then we can destroy the ball so that we don't have balls floating off in space, etc. And then I added a marker just so I could see it a little bit better. So with all that, let's take a quick look at the event begin play here, and then we'll talk about some of the logic for scoring. So the event begin play here, this target score blueprint is a variable that I created so that we can specify through that picker in the level which scoreboard we are referring to.
Okay.
So this is how we do that. It's just publicly exposed variable here.
And the reason we did this is to make it easier to reuse. Basically, Wes could make one blueprint that I could then take and set up in an entirely different way, but still have all the same scoring functionality and logic and things like that. It's just a better way to work when you have to work with multiple people.
And once we've created that reference to it, we can then get the widget component associated with it. So it's referring to this widget here.
Okay.
So it's getting this now. And I've seen this on the forums and Answer Hub a couple times. How do I actually access that widget and the functionality for that widget if it's an actor? You need to get the user widget object. And once you get that, then you can cast to your UMG widget blueprint. And then you can access all the functionality from it. So what I did is I just created a variable for our widget blueprint so that I could reference it a little bit later. Created a quick function here to initialize the display, and all that does is get the balls remaining, the cans remaining, and populate it with the variables so that it gets updated whenever we start our game. And then we have our target reset button. We actually didn't look at this blueprint, but we could take a quick look at it because it's really, really simple. So here's our reset button, which is right here on the wall. If we open that up. And again, this can be dragged and dropped and used in any of the Carnival games that we try to create here. It's just a static mesh representing the button, text renderer component, which kind of was a cheap way to do this, but tells you what to press. And then we created a trigger. And when the player moves his arm into this trigger volume and presses LT, that will signal a reset. And we're checking that right here when overlapping the trigger. Is it the first person character? If it is, we're going to allow input to be provided to this blueprint. When we leave that trigger volume, then we no longer want input to be received from this blueprint. So when input is enabled, we can press the left trigger and call an event dispatcher. And then we're going to destroy the actor just to kind of give us a visual indication that we've pressed the button. Down the road, we'll change the material of the button to green or something to let you know that you've pressed the button.
It's an iterative process,
Yeah,
right?
I mean, I needed some kind of visual cue that I pressed it, so we're deleting it for now. So this event dispatcher, if I hop back over to the actual can game blueprint here, we are binding that now to a function in here that will reset our game essentially. So we've bound it, and we can call begin restart here, and begin restart will update our scoreboard, let you know that we're going to restart the game, starts a countdown, etc., begins counting down, and then once it reaches 0, actually we are just reloading the map. Again, down the road we'll set it so that it wipes everything and respawns everything in its correct location. But for now, just to test, we just restart the map. Let's see, what else do we have here? Let's take a quick look at the actual landing in the scoring area here. So the first thing that we do when we land in the scoring area, we're checking to see, is it a ball that landed in there? If it is, first thing that we're going to do is turn off generate overlap events. What I notice is we don't want it to re-trigger multiple times if the ball is bouncing around in there, so we turn that off. Then we update our display for the cans remaining. We display that on the HUD. And then we call a function called all clear check. So we're checking to see, have all the cans been knocked down at this point, each time a can lands in there. So we can call this, and all this does is say, is the cans remaining equals 0? If it is, then we're going to set the game over text essentially to visible and say that you won. If it is not, then we are not going to do anything. When we are landing in the scoring area, we're checking to see if it's the can. If it's not the can, then is it a ball that landed in there? If it is, then we're going to decrement our balls remaining, and we're going to call a function that updates our remaining balls that we have to use. And that's just a display right here. Once we update our display, then we're going to check and see if we are actually out of balls at that point. And all that's going to do is say, similar to the cans remaining, are all the balls, do you have 0 balls left? I added a little bit of a delay here rather than once you are out of balls saying game over, just because you could throw a ball and there could be a can kind of teetering around on the platform and then kind of fall over.
Okay.
So giving you a little bit of a delay before actually saying, hey, game's over.
You're way nicer than a carny.
Yeah, it's still kind of difficult, but realistic, right?
Yeah, that's true.
So this is all very straightforward stuff. And the last bit of business that we do is, if we are out of balls and we determine that no, we still have cans remaining, then we're going to say that you lost. So that's really the gist of it. There is one little thing that we did, when a ball leaves the play space, so on end overlap. So we've thrown a ball and we've thrown it, over the wall, essentially, make sure that it's a ball. Then we're going to destroy the actor. And we're going to say that the ball is destroyed. The ball destroyed is just going to hop right up here to this script, decrement our balls, and run that same check. How many balls do we have left, setting, the display, etc. So that's really it. I mean, it's all physics based. It's nothing too complex here. Again, I haven't had that much experience with motion controllers just yet. We got this up and running in like a day. Really, really quickly. So,
and if you do notice, I'd say almost 99% of this is just standard blueprint functionality. You notice the only thing that we had to do to get the motion controllers to work is just make sure that we had the motion controller component added to it, and that we had that on our first-person character, and that literally that's it. Like, it's so awesome to be able to work with something.
It's very easy.
That's super easy to set up and basically set it and forget it.
Yeah, a lot of the stuff that's shown here is very entry level. If you've had any experience with blueprints or any experience with generating overlap events, this stuff is very easy to set up. And hopefully, when we have a finished version of this project, you'll be able to see for yourself and can kind of tinker with it, make it your own. How are we doing on time, and how are we doing on questions? Is there anything?
I've actually, so if you guys have some questions, please put them in the chat. I actually only have 3 questions so far.
Okay.
So let's jump into the questions, and I'll jump into some material and optimization stuff.
Sure.
So the first question I have right now is: are there any games that have implemented a 3D space mouse on a 2D curved screen? I want to have a mouse drag around I want to have a mouse drag around UMGs around the character, so the surface is inside of the sphere, but have trouble doing this in UE4.
Yeah, I kind of get what he's after. He's kind of after a virtual reality menu navigation type thing.
Like a screen like this.
Right. Even if you had like an inventory, like there's an inventory tutorial series out there, if you guys have seen it, with drag and drop functionality. He's looking for that in VR space. So having a motion controller and being able to kind of move things around. Okay. I haven't actually experimented with that, but I love the idea and love the concept. So that's maybe something that we can experiment with, trying to roll into these, carnival games that we're working on here. Maybe we have some kind of simple match 3 thing where we can, in VR space, grab something and pull it and move it.
Oh yeah, we can do something like that.
A simple thing like that, something like that. But I don't have an answer for that right now because I haven't experimented it at all with myself. So maybe something down the road we can experiment.
It sounds feasible.
Yeah, it totally sounds feasible.
It's something we need to just work out and figure out how to get it to work. Okay, so the next question I got here is, in my game, I add child actor components that are attached to each motion controller on Construct. These are my base hands in the game. I want to be able to switch other blueprints that have their own meshes and fire their specific projectile blueprints based on which one of the Hydra buttons is pressed. What's the best way to hot switch child actors? And are there meshes but still have general trigger actions work across the board? So basically, I think he wants to you throw down your ice hands to pick up your fire hands.
Right. Yeah. There's a number of different ways you could go about doing this. It's really going to be handled in your communication, just how you communicate with your different actors. Probably what you would want to do is have those not necessarily be child actors of something, just make them their own separate entities, their own separate actors, and then have a variable that you can drive through script and update, kind of like what we were doing here. So you have a trigger volume, and you go to mouse over something to pick something up, populating that variable at the time that you overlap. You could get what actor it is that you've overlapped, pass that through an interface or direct blueprint communication. It just depends how you want to go about setting it up, but I would look into blueprint communication as how to pass that information between. It's totally feasible. Maybe that's something that we can experiment with as well.
Yeah, like another
Different
game.
way. Yeah, different things that you could pick up and throw, but totally doable.
So, question: how would you pick up a cup by its handle? Would you have to attach the handle to a hand socket? I mean,
yeah,
that's what I would do.
It's really, yeah.
mean,
If the cup had an actual, depending on how you set it up, if it had like a socket on it, or if
That's
it
what I was thinking.
Yeah,
go
you
through
could add a
socket.
bone for it
'Cause you
inside
could
the
do a-
handle, and have a bone inside.
Well,
of your
you could have
hand.
a socket on the static mesh, and then a bone on the hand that the socket pops right into. So
Yeah, it's all done. Let's see if we could actually show that here. It's first-person character here. Yeah, so on our attached to here, you could specify the socket name. If we had a bone inside of our character's hand, like right hand grip, we could tie that in right here, or type that in right here and attach directly to that socket. Getting the actual orientation so that it's positioned inside of your hand could be some things that you could, some ways you can get around that by setting, how you set up your static mesh, etc. But totally doable. It would be done through one of these methods here, probably.
Okay, and the last question I have for the time being is, I've seen you use the first-person character pawn, but it doesn't enable the HMD to be aligned with the virtual and physical floor. How would you set it up so that it aligns to have collision to the head? I'm not sure what exactly they mean right there. The last part. I'll read it again.
Yeah.
It says, I've seen you use the first-person character pawn, but it doesn't enable the HMD to be aligned with the virtual and physical floor. How would you set it up so that it aligns and have collisions to the head? So I think maybe what he's saying is, it sounds like two questions, like the floor isn't lining up, the virtual floor isn't lining up with the real world floor?
Yeah, he said something about collision, right? Not getting collision or something. Yeah, I'm wondering if he means like, because right now we have our character that's very vertical.
So that it aligns and has
Yeah, so it has collisions on the head. So I may be wrong on this, but what I think he's referring to is, so we have our player character here. It's very vertical. So what happens if we lay down on the ground? So we're in a prone position, right? And I have my headset on, and I go to look down. My head passes through the floor. I'm not quite sure. It'd be something I'd have to experiment with. Could probably add a collision box around the camera,
I was
maybe.
thinking you would add it, yeah, like if I'm
That's
thinking if you
attached
had
to
like
it?
a headless body, so when you look down, you see your body, like there would just be a collision around where my head would normally be to stop me from penetrating through the world. But that also, I mean, collision will only work to a point.
Yeah.
You still might pass through something or have something go up inside of it or something like that.
Yeah, I'm not sure if that's what he meant, but yeah, that's definitely something I haven't experimented with either, but something we could look into.
Okay. All right, so that's all questions I have for now. Let's go ahead and jump into the material stuff. So,
Okay. Let me bring that up.
yeah, bring that one up.
This one?
Yeah, carnival game scene. Okay,
Okay.
so
I'll drive.
yeah, I'll drive really quick. So I'll go over this really quickly. Nothing that I made in here is too crazily overly complex. It's very, very simple stuff. The reason I went so simple is to start out with something very small and then build upon it as I needed things. And what a lot of people will do going out of the gate is they have these grandioso plans, and when they try to put everything into action, they start running into problems because they either try to make shaders or meshes or textures that will meet all of these requirements instead of starting off small, very, very small, and then building as you need. And I'm going to show you exactly what I'm talking about here. So the first thing I built was this little table right here to put the milk cans on. And all it is just this static mesh right here that's got two material IDs on it, one for the metal right here and one for the table. I could have put this all into one single texture and then generated a texture for it and baked that. The reason I picked 2 material IDs is for the time being and how small this table is, you're not going to see a huge hit in your performance from just having 2 of these. Now remember, each one of these materials up here signifies a different render pass. So this will require 2 render passes. Now, if I had 20 materials on this, and I use this thing 20 times, then that would be a problem. But even if I use this simple one with just a 2 on it 20 different times, my rendering impact is not going to be
marginal.
Yeah, it's going to be very marginal. And it's not ridiculously high poly. It's like it probably could have gone a little bit higher on it. It's about 1,100 triangles. So not ridiculous, just enough that at a distance you can tell what it's looking at. Let me escape out of that. Then the other thing I made these, let's actually go into here and we show you the bottle here. So the bottle, again, what I did is I went inside 3D Max and I just took a spline and I just made the spline an outline of a bottle and used the lathe modifier on it, and it just made it into a bottle shape like this, and then I adjusted the spline to get these nice corners here that you're seeing. Now, I could have done all of this stuff inside of the normal map, but in VR, normal maps kind of break down a little bit. You still need them, and they'll still work, especially for reflections, but using a normal map to display a lot of detail that you normally would, it just kind of breaks down in VR. So you have to start using more Geo. But hey, luckily enough, Geo is very, very inexpensive to render. And then we can see like my bottle's got everything. UV is laid out like that. And then if we, oh, wrong one. Uh-oh. Clicked off the compositor there. And one second here.
Screen.
Yeah.
Probably close.
There we go. It was just something with the compositor. So all of these objects, minus the one I just looked at, let's hope I am remembering this correctly or have the right version of that. Oh, there we go. Okay. I set up light maps for them as well, just to make sure that, you know, if somebody wanted to grab, you know, like this baseball, for example, and just use it as a prop in the level somewhere, it wouldn't get a light mass error or anything like that when you went to go play. Let me see what else. The rings, really simple to make. They're literally just a torus that I made inside 3D Max. I went out and found out what the size for rings were, and I made them that size in centimeters, which actually, surprisingly enough, everything that I've made has had to been scaled up by about 2 times.
Yeah,
a lot, like more than I thought that it would have to be. Because while it was the right scale, it felt like I was this giant, and I had these little tiny objects in my hands. And then, so let's see here. If we look at my textures, you can see that I've got, we'll go over this texture. We'll go over this texture in a second. You can see I got basically, I only imported textures as I needed them. So instead of importing all of the textures from the starter content or something like that, I just imported this wood. This is a normal map I made for the milk can, and I just made this in Photoshop using gradients and basically black and white. Because again, I don't want to just add a bunch of extra stuff to the project that I'm going to have to remove later. You're obviously going to have to remove stuff as the project, as you develop, but this way, again, we're starting off small and we're building up to where we want to go. I want to actually show you my materials, because my materials is something I really enjoy making, but you can see I have 2 parent materials here. I have a material glass, matte glass parent, and I have a matte object parent. Now, what a lot of people will do is they'll just go buck wild and they'll make a massive, massive parent material that has every single combination or every option that you could ever imagine to turn on. Well, what I found out in my years of development experience is that artists generally will do everything inside of their spec or their roughness or their normal map or their base color. And they'll tweak a little bit in the shader, but they're not going to tweak as much as you think they will tweak because they probably don't know what half the options do. So with that in mind, when I started making this stuff, I literally just started off with a base color, a metallic input, a roughness input, and that was it. As I started to build objects and as I started to get objects that needed normal maps and things like that, I started adding what is known as static switches. And you can see a static switch right here. And this one is use base color texture. So the this defaults to false. So when I make a new material instance, what it's going to do is it's just going to use base color. And if I want to use a texture, I can come over to the material instance and turn that on, and I'll show you how to do that right now. So we'll pick up this guy right here. So this is just one of the rings that I had on there. And you can see over here my static switch parameters. I have a normal texture and a roughness texture turned on. But let's say I wanted to use base color for this guy. So I'm going to enable it. You can see my base color came out right there. It's now using a texture, and you can see I have a texture down here. So let me come down here, and then, you know, I could pick some other type of texture, whatever it happens to be, and then I can disable it by doing this. Now, be careful when you start enabling and disabling switches. It's kind of a double-edged sword. Yes, they're super powerful, but they can also eat up your shader cache.
They're pretty expensive, right?
Yeah, well, it generates a lot of permutations.
Mm-hmm.
Yes, it ends up eating. Basically, it will calculate a permutation of the shader for all of the options that you have on. So if you start turning on options and turning them off, you're going to bloat your shader cache with all these useless shaders. So it's best to just not go buck wild with them, but use them just like I did. I want to use a color or a texture, or I want to use a value or a texture, and then that's it. So you kind of reduce the permutations of the shaders. So they're very powerful, but use them judiciously, because you could end up shooting yourself in the foot with them. The other thing I want to talk to you guys about is, I'll show this for you. So this is, I don't know if you guys know who this is. I'll zoom in on him a little bit, but that is Nick Whiting right there.
That is fantastic.
He said we couldn't make a carnival game, that we'd throw stuff in. So I told him he was crazy. We would totally make a carnival game that included him. So this is it right here. Now, the reason I wanted to show you guys this is not particularly for Nick's face, but for the objects that are behind it.
He zoomed in on it. That's awesome.
So I went into 3D Max, and I was just messing around with the cloth modifier and you know, just bending some cloth over these things. And I have 1, 2, 3 different objects, and each object has 2 textures on it. Now, normally this wouldn't be too bad, but since we're going to have a lot of boosts, I'm going to want to be able to have a lot of objects, and I want to have them in as few draw calls as possible. So this is where we're going to talk about this awesome new tool, called the Merge Actor tool. So first, we need to go here to Editor Preferences, go down to Experimental, and make sure that Actor Merging is turned on. Once that's enabled by just clicking on the checkmark box there, you can go Window, and it's Merge Actors, which is actually already over here. I'm going to pull this out so we can see it. And what you have here is just a bunch of options for merging the actors. And what that means is basically it's going to take all of these actors. It's going to put all of the static meshes together into a new mesh that's one static mesh with, and depending on the options, 1 to 2 materials, depending on how many you have inside of your atlas. So the first thing is do we want to generate a light map? Well, yes, we do. And we're going to set it to channel 1, which is the second UV set, which it has to be on. And we'll give it a size of 512. We can also say, you know what, for this, I want to actually merge these actors together just using the third LOD. That's actually pretty cool if you're doing something, say, for the far off background, where you needed it to be low poly, but you also wanted it in one draw call.
Right.
For us, we don't have any LODs at the moment, so we're just going to set this to 0. Import vertex colors will basically merge all the vertex colors together if you have them. Pivot at 0, 0, 0. This is probably one of the most important features of this. Basically, what this is going to do is where it sees this in the world, it's going to grab it. Oops, let me undo. It's going to grab it. It's going to merge these 3 together, and then it's going to take its pivot, and it'll put it at 0, 0 in the world. Now, the reason you want that at 0, 0 in the world is as soon as I drop this piece back in, I just come over here to my location and my transform, I zero them all out, and it will be in the exact same place that it originally came from. And I'll demonstrate that here in a second. Cool. So we can have it placed in the world, so it will remove these and put the other one in place. Now, I do believe this has a little touch and go sometimes, so I generally turn it off and just manually replace the things that I want. Merge materials. Now, merge materials will be off by default. What merge materials will do is it will take all of the materials that are used to create this object, flatten them down, and then set them up in an atlas so that I will have a wood material and then the different materials or the different, I'm sorry, I'd have a wood texture and then the different textures for the different colors.
Right.
And this will make sense once I run this tool. Now we have in the merge materials, we have export normal map, export metallic, roughness, and specular. And this is just saying, hey, whatever maps, whatever texture maps we're using for these guys, make sure you go ahead and export those when we make the atlas. So we're going to make an atlas for this now. So I'm just going to click on the merge actor button, okay? We'll do this in merged assets here. And it's just called SM merged underscore because I have SM. So we'll do SM merged tents test. Okay, so we're going to save that. Let me make sure that it actually goes into there. There we go. We're going to save that. And it's going to take just a second here. Okay, so now we can see, now you see I have my merged asset. It's got 2 UV channels, so it's got a light map on it. It uses 1 material, and it's about 14,000 triangles, which needs to be optimized a little bit. But what we can do now is I can grab this, and if I select these and I hit Shift-E, which will, they're all the same one, it's just different meshes on them. I hit delete, we'll get rid of it. I come back over to this, and I'm like 0, 0, 0. And yes, so now you see it's in the exact same spot as it was before. Now all I have to do is just rebuild my lighting, and that's it, it's done. And it's ridiculously cheap because it's one draw call. You know, I took this, which would have been 1, 2, 3, 4, 5, 6 to render all of these, and I've just now made it into one. And we can see my atlases here. Now, these were just raw colors that I was using. That's why you see the red, or I'm sorry, the red, the green, and the blue, and the wood for the base color. If we look at the normal map, you see that we just have the normal map for the wood here. And then if I look at the roughness, you can see I was cheating and I was using different different textures. So I have like the wood and the roughness here, this wood pattern, and this is some clouds. The reason I did that was just sometimes the surface just needs some noise. And since I'm already using those wood textures and it doesn't really, you just need noise.
Wood,
so might as well use something. And I experimented with a couple different textures that I was using, and those ones looked good enough for what I was trying to achieve. And that's why I decided to go with it. But again, I've moved these, they're all 1024 by 1024. So I have greatly optimized this asset. And if I come here and I do a size map, one asset's we're missing. Okay, so it's not showing me everything here. But what I wanted to try and do, which I don't know if this is going to work or not. No, it's not. Oh, maybe. Hold on. And we'll click on the textures as well. And we will say red, green, blue, and you, and yeah, so we're looking at a massive, we've got 5.6, 5.6, 5.6, and maybe it's because I need to save it. Let's try this, save all. Okay, and then we'll do this. We'll try this size map here. I'm not sure why one asset is missing, but as you can see, we're at 964 KB.
Even
looks like
without that other asset, you can see it's a massive savings.
Yeah, it's just a huge savings overall. And while this is a small scene and profiling it wouldn't actually give us any usable results, when we have 20, you know, I shouldn't say 20, when we have like maybe 5 to 10 carnival games, these are some savings that you will notice as these things stack up. So, and then we've got the lovely Nick Whiting.
So she was panning in for us.
Yeah, so let me log back in and see if there's any other questions. And let me check my notes really quick. Oops. My computer's being very slow. While I wait for this to boot back up or to log me back in, let's see if there's anything else that we want to cover about materials and actor. Oh, one other thing, the actor merging tool is an experimental tool.
It's experimental.
So what does experimental mean? Experimental means that we've implemented it, we've used it, but we don't QA test it a lot. So use it at your own risk. Make sure any time you use an experimental tool in Unreal, as with anything, make sure you saved often because it could just end up just crashing, and we don't want you to lose any of your work or anything like that. So let me see here. I'm going to check the questions here, so just give me 1 second here.
Jelly put a monkey sitting on his shoulder. Just happened to look up at the screen and we have a monkey in our carnival game now. Nice job, Jelly.
So nope, that looks like it's
How are
all
we
the
on time?
questions. About 5 minutes left. It's almost
Oh,
3
really?
o'clock. So I'm gonna click through my notes here. Oh, one of the other things I wanted to talk about the merge actor tool really quick. So the merge actor tool, you can use it. And we want to show UV channel 0. Okay. For the best results for the merge actor tool, you need your UVs to be in the 0 to 1 space. And what I mean by that is basically this is 0, this is 1 down here. Depending on your coordinate system, it could be the other corners, but that's basically what it is. And if you don't have your stuff in the 0 to 1 space, like for example, you might have a piece that you need to tile for a really long wall, so it doesn't go in the 0 to 1 UV space.
Yeah.
What will happen is when it makes this atlas, it's just going to chop it off at the sides. So what will happen is you'll be missing your tiling like in the middle of your texture.
I see.
That's just one thing you need to consider when you use the merge. It's not to say that it won't work, but you might lose some texture fidelity, and that's the reason why. Ways to get around this is to add a few more verts inside your model, and that will cut up your model, but it'll also cut up your UVs so you can scale them a little bit smaller, a little bit bigger, depending on your needs. But also, everyone should be familiar with 0 to 1, because basically think about your diffuse or your UV channel 0 needs to be set up exactly the same way as your light maps. If you keep that in mind, you won't have any problems. Yep, that's pretty much that's all that I've got. Material instances, we have a lot of documentation on them. I know that they can be a little daunting at first to get into, but trust me, once you start to put them into your
It's the bread and butter.
workflow, and also material instances work directly with blueprints, right? So you
Yeah,
expose a
can
parameter
access
in there,
parameters, yeah, change
and you're able to, start doing stuff dynamically, changing parameters dynamically. And we'll show you guys some more of this stuff as we make some more carnival games. So, oh, we got one more question here. How accurate are the controllers? Is the movement noisy? Not at all. They're freaking ridiculously accurate.
They're pretty accurate, yeah.
Yeah, they're very, very accurate. They're so accurate that you don't notice how accurate they are. It's just like using a mouse or a keyboard in real life. When you have the motion controllers and you're doing things, what you actually end up noticing is if there's any like visual slowdown in the game.
Yeah, they become more apparent.
Yeah.
Things like that become more apparent, yeah.
This is not in 410. This is on 492.
Yeah.
We might end up doing it in 410, but we'll see what happens. Let's see. That's it. That's all the questions that I see on here. That's everything I got on my notes. Oh. How about shooting bow? Oh, shooting a bow with the motion controllers.
We can do that for a
we
carnival
can
game,
do that. We got a lot of carnival games planned. We got shooting gallery game, whack-a-mole, my favorite skee ball. Yeah, skee ball is what actually got us talking about this thing in the first place. Like, how easy would it be to do a skee ball thing?
Yeah.
And then, of course, how many balls can you throw through?
Yeah, we could do like a bow and arrow shoot like at a balloon. Should be
Okay,
pretty easy.
that would work. Yeah, that would work. But first, we're doing the the Nick Whiting ball toss game.
Yes, indeed. And with the way that blueprint was set up, you could easily put this in that.
Yeah. With the
format.
other blueprint, we can easily drop it in, and that's what we'll probably do that for our next stream. Is
For
we'll
the
get
next
some
one,
more.
We'll have some more examples.
Yeah,
and
we'll have
show
some
how
more
we do
polished
that.
examples, and yes, Nick has seen this. I actually showed it to him while I was building it, so I totally stalked his Facebook page, and he's actually photobombing somebody in this picture, which made it work perfectly. But the picture's only like 400 by 500 pixels, so I had to go in and like fix that. So I need to do some paint up on it and fix some things like that. So, is the PlayStation Move going to be able with PSVR? Don't have any idea about that. I'm assuming that it would be, but
we haven't done anything with those yet, have we?
no, we haven't.
We should look at
it's
that,
just
yeah.
hard to get a hold of.
Yeah.
So
We've only done the Steam stuff and Oculus so far.
yeah, Steam stuff and Oculus so far.
Yeah.
So, but I have some requests to do that stuff. So as soon as I I've got actually PlayStation 4 now, and I know where I can get the hardware.
Okay.
It's just what can we do with it? I'm not really sure. There might be something that we can't show or something like that.
Yeah,
I have no
true.
idea. So we'll look into that. But for our next few streams that we will be doing is going to be mainly focused using motion controllers with the Carnival games. So that is all that I've got.
I think that's all that I got.
All right. Well, if you guys got any questions or anything like that, or something we didn't cover, please post to the forums. We're on there all the time.
Yeah, you
and
can respond to the individual thread for this too. We take a look at those. I know there's a
Yeah.
couple questions in there already.
Yeah,
so.
I'll follow it for the next week or so. And then after that, just post in the VR forums or Blueprint forums. And we will see you guys next time. Thanks for
Thank
tuning
you
in.
guys.